In this video, I will attempt to synthesize potassium manganate. I did not watch any YouTube videos on this process, so I would not be influenced by how others may have approached this procedure. Potassium manganate has interesting properties and can be used as a precursor to making potassium permanganate. Unfortunately, it is difficult to isolate potassium manganate from the mixture containing potassium hydroxide in which it is formed. First, I weigh out 3 grams of manganese dioxide. Now I weigh out 5 grams of potassium hydroxide. This is in excess of the amount required by stoichiometry. Besides compensating for the unknown quantity of water in the hydroxide, it is hoped that maintaining a high pH in the final product will prevent the decomposition of the potassium manganate. I have read that this reaction is to be done by heating the dry ingredients together until they melt. This forms potassium manganate as oxygen from the air is incorporated in the reaction. Even though I think it will likely fail, I try the reaction in an aqueous solution with the hope that the extra hydroxide will prevent the decomposition of any potassium manganate that forms. So after adding about 50 milliliters of water and a stir bar, I turn on stirring and set the heat to maximum. I cover the beaker with a watch glass to slow the evaporation. After about 7 minutes and the liquid is near boiling, I see no evidence that any reaction has taken place. I allowed the liquid to cool for a few minutes while I measured out 50 milliliters of 3% hydrogen peroxide. I slowly add the peroxide to the warm solution a little at a time in hopes that the reaction will occur. After having added all of the peroxide, I examine the contents of the beaker. I see no evidence that anything has changed. So moving on to Plan B, I call into service my stainless steel ashtray and proceed to transfer all of the contents of the beaker into the ashtray. I set the heat to maximum and wait for all of the water to boil away. I place a wooden stick under the lid of the ashtray to hold it open so the steam can escape. All the water is gone, and I have allowed the container to heat for 10 or 15 minutes. It is difficult to see on camera, but there's a dark green substance in the bottom of the ashtray. Now I am preparing a solution of potassium hydroxide that I will soon use to aid in removing the reaction products from the ashtray. First, I use a spatula to scrape loose as much of the green substance as I can and dump it out onto a sheet of paper. Now I pour some of the hydroxide solution into the ashtray and let it soak. Here I transfer the powder from the paper into a petri dish and set it aside. I use a glass dish to catch any spills as I transfer the contents of the ashtray into a beaker. I use the remainder of the hydroxide solution to help transfer the powder from the petri dish into the beaker. I have set up a funnel with a piece of cotton in the neck to try and filter out the solids from the solution. After a while, the filter seems to be clogged, so I get a larger funnel and a fresh piece of cotton. At this point, it looks as if there is still some product that could be recovered from the solid still in the beaker. I pour in some plain water and swirl it around. I have set up the small funnel again, this time with a small coffee filter instead of cotton. As I pour the solution into the filter, I observe that it goes through rather quickly. So after setting solution B aside, I notice some sediment in the beaker of solution A. Because the small coffee filter works so well, I decide to use it to filter solution A again. I had noticed that when I removed the cotton from the funnels, it crumbled away, showing that it had reacted with the solution I was filtering. I think coffee filters will suffer this as well, but because the liquid passes through much quicker, it has less time to react and destroy the filter medium. So I can't think of an easy way to purify the potassium manganate by removing the potassium hydroxide. I proceed to do a few simple tests with the two solutions that I have. So with 2 small beakers full of pure water, I add some of the manganate solution. First, from sample B, then from sample A. Sample B is what was washed from the sediment in the bottom of the beaker after all of the liquid had been decanted. Notice that sample B turns pink almost instantly, while sample A does so much more slowly. So I try something else by adding a little vinegar to each of the beakers. I try something a little stronger by using some dilute hydrochloric acid. The results are not really spectacular. I try something different. This time some of the 3% hydrogen peroxide is added, and the results are interesting. I have no idea why solution A turns clear and solution B only gets a little more pink. If you have any idea, leave a comment. One final thing, I check the pH of both beakers. They both seem to be about 4. I decide to combine both solutions and save for future experiments.